We are here at the Campus Agricultural Center in Tucson, Arizona, which is part of the Southern Arizona Experiment Station. Perfluorinated compounds known as PFAS are emerging contaminants that have been shown to cause adverse human health effects, and yet they are thought to be in the bloodstream of everyone in the United States. PFAS is ubiquitous. It can be found in the environment, in soil and water, and in personal care products such as lipstick or mascara, and even food packaging products. It can also be found in household dust and many other items we use at home because of its water repellent and anti-stain properties. Due to the prevalence of PFAS, it inevitably ends up in wastewater and subsequently biosolids, albeit at lower concentrations than many of the other items listed here. Concern over PFAS in biosolids has raised questions about whether land application of biosolids and subsequent leaching of PFAS into groundwater used as a source of drinking water is a significant source of human exposure to PFAS. Hi, my name is Ian Pepper, and I am a Regents Professor at the University of Arizona. So I'm your very own Dr. Pepper and also the Director of the West Center. I'm glad to be the project leader of the National Collaborative PFAS project that you were taking part in, and I hope you have all read the detailed standard operating procedure, the SOP for the project that we sent to you earlier. You have offered your land application plots as a site to be sampled as part of the national project. This video you are watching is designed to guide you through the process of being a project site. Let me begin by saying that we will be sending you a kit with some of the items you will need during the sampling process. Some items we cannot send to you by mail, and you will need to purchase them. However, we will give you information on exactly what to buy, and you will be reimbursed for all expenditures by sending us an invoice and receipts. We will also be arranging a virtual meeting with you 2 to 4 weeks before you collect soil samples. PFAS is ubiquitous and is found in many household products, including the clothes we wear and the personal products that we use, such as shampoo and sunscreen. We need to be very careful about preventing contamination of soil samples with extraneous sources of PFAS. As an example of the care that is needed to prevent contamination, we request that on the day of sampling, you do not take a shower and are careful about the clothing that you wear. Additionally, the equipment and supplies used in the field need to be PFAS-free. This includes PFAS-free water, which is needed in the decontamination process. We would like you to send us a sample of your DI water in an 8-ounce HDPE, not LDPE, container at least 2 weeks before sampling to allow time for PFAS analysis. The list you are now seeing outlines the items that are prohibited or acceptable during soil sampling and is also included in the written SOP provided to your site. Note in particular that anything containing Teflon is not allowed. Additionally, more detail about procedures required to prevent contamination will be discussed. At first, the steps that are needed to prevent contamination are overwhelming. However, it is actually not rocket science. If you are careful and follow the rules, you will be fine. Essentially, we are asking you to take surface and depth soil samples from 3 different plots. Please note that we are distinguishing between the words site and plot. Your site is your overall geographical location, for example, Tucson, Arizona. Plots are the actual areas where you will get your soil samples. These include a control agricultural plot with no history of land-applied biosolids, a land-applied plot with a lower biosolids rate of application, and a land-applied plot with a higher biosolids rate of application. We would like you to get 3 soil cores from each plot, each separated by 25 to 40 feet. These 3 soil cores represent 3 replicate soil samples from each plot. For plots where the depth to groundwater is significant, we would like soil samples to be collected at the 1, 3, and 6 feet depths. If the depth to groundwater is less than 6 feet, take a sample at the 1 foot level and half the depth to groundwater. If it is not a 6 foot depth, a note taker should document the depth that we get that sample. For each site, there are 3 plots. For each plot, there are 3 cores, and for each core, there are 3 soil samples. Thus, there will be 3 times 3 times 3 soil samples, resulting in a total of 27 soil samples. These soil samples will be sent to the University of Arizona for processing and PFAS analysis. For each plot sample, there needs to be the following 3 blanks. After all 3 plots are sampled, you should have a total of 9 blanks. First, the travel blank. This is a 250 ml HDPE container filled with PFAS-free deionized water. The container is capped, transported out into the field site, and ultimately back to the lab without being opened at the site. Second, the field blank. A 250 ml HDPE container is filled with PFAS-free deionized water, capped, and taken out into the field. At the field site, the container is opened and the water poured into an empty 250 ml container. After capping the container now filled with water is returned to the lab. Finally, the equipment blank. After the first 1-foot soil sample is collected, the auger is decontaminated. We will describe how to do this later in the video. Following decontamination, PFAS-free water is poured over the auger and collected in a small clean, PFAS-free stainless steel bowl and then poured into a 250 HDPE ml container. Note that 100 to 150 ml of collected water is sufficient. Prior to field sampling, gather all equipment needed for the process. The equipment list and photos of items is in the SOP that was sent to you. A 4-person team should be used for the soil sampling. Our team is a digger, Jeff, a sample collector, Lois, and a decontaminator, Leandro, and finally a note taker, Sarah. Initially, everyone involved with the sampling will put on PFAS-free overshoes and wash hands, then put on fresh, non-powdered nitrile, not latex, gloves. Additionally, a fresh pair of gloves should be donned at several points throughout the soil sampling process. These points will be identified for you. Two tables are set up in the field, each separated by 10 feet. One table is for removing soil from the auger, the other is for decontaminating the equipment. Prior to sampling day, decontaminate all equipment in the lab, including the auger, bowls, and spoons. Additionally, decontamination of equipment will be conducted multiple times in the field. Here is the process for decontamination. First, for any piece of equipment, remove loose material with a brush. Next, wash with tap water in a bucket with a small amount, about a capful, of Alkanox or Liquinox phosphate-free detergent. The equipment is now essentially clean, but needs to be rinsed. First, triple rinse with tap water. Second, triple rinse with lab-provided PFAS-free water using a squeeze bottle. Third, rinse with pesticide-grade methanol with a squeeze bottle. Collect in the rinsate for safe disposal. Finally, wipe with Kimtech wipes and allow equipment to completely air dry. Following decontamination in the lab, prior to going to the field, the equipment is stored in a new large 10-gallon Ziploc bag for transport. If decontamination is in the field, the equipment is now ready for reuse. New gloves should be donned by all team members except the note taker after each decontamination routine prior to handling cleaned equipment. Soil augers 4-inch in diameter will be used to create a soil core to a depth of 6.5 feet beneath the soil surface. Actual soil samples will be collected between depths 6 inches and 18 inches. This is the 1-foot sample. 30 inches and 42 inches. This is the 3-foot sample. And 66 and 78 inches, and this is the 6-foot sample. Soil in between the actual samples will be discarded at least 20 feet from the soil core. These are the 0 to 6 inch, 18 to 30 inch, and 42 to 66 inch depths. Note how the locations of the important depths are marked with an ultrafine Sharpie on the auger, so there is no need to measure soil depth with a measuring tape. Here is the 6-inch depth, then the 18-inch depth. These marks define where the 1-foot sample depths are. Similar markings define the 3-foot and 6-foot soil depths. Using a clean, decontaminated auger, the surface 6 inches of soil are removed. The soil auger, when full, will remove soil to a depth of approximately 6 inches. We would like you to core down to a depth of 6 inches and discard this material at least 10 feet from the hole. Keep in mind that any time you are coring, soil will be displaced by the auger and push up over the top of the auger. This is fine. All of this soil is part of the targeted depth soil. Depending on soil texture, you may need to core a couple of times to fully remove the initial 6 inches of soil from the hole. The first soil sample collected between the 6-inch and 18-inch depths will be obtained from 2 6-inch corings. Prior to this, the surface 6 inches of soil is cored and discarded. For this first soil sample, decontaminate the auger after removing the surface 6 inches. Carefully, the digger relocates the auger into the 6-inch hole and cores down again until the auger is full, a 6-inch soil core, if you will. The digger then retrieves the auger with soil and scrapes off the top inch of soil from the core away from the hole. This is to remove any possible contamination from soil that previously fell into the hole from above. One of the major ways that depth samples can be contaminated is from displaced surface soil falling into the hole. Therefore, whenever the actual soil samples at any depth are being collected, the top ½ inch to 1 inch of soil should be discarded to remove potential contamination from above. The remaining 6 inches of soil are now moved within the auger to the sampling table, where the sampler retrieves the soil from the auger into a stainless steel bowl. If you are working with a coarse textured soil, it may fall out of the auger in transit to the table. It may also fall back into the hole. If so, go get it. You may also need to place the stainless steel bowl closer to the hole in this case. Don't worry if you lose a small amount of the soil sample. We have plenty of soil, and we now have soil between the 6-inch and 12-inch depths. Repeating the process allows us to collect soil samples between the 12-inch and the 18-inch depths, thus completing the sample for the 1-foot sample. The contents of the 2 cores containing soil between the 6 inches and 18 inches are thoroughly mixed in the bowl. An approximate 2-pound sample is then placed in double Ziploc labeled bags, then placed in a cooler with ice, not chemical freezer packs. The remainder of the soil is then discarded at least 10 feet away from the sampling area. Soil between the 18 inches and 30-inch depths is removed via 2 6-inch cores in a manner similar to the procedures used for the first corings. At this point, just prior to getting the 3-foot soil sample, the auger and other equipment is fully decontaminated as described earlier. The 3-foot soil sample is now collected from 30 inches to 42-inch depths. 2 or more corings will be needed to remove all the soil to the requisite depth. When placing the auger in the borehole, again, be careful not to displace soil from the upper surface levels. Also remove the top ½ inch of soil after removing the auger from the hole as a secondary precaution against decontamination. Place soil in double Ziploc bags into the cooler with ice. To reach the 6-foot depth, you will likely need to put an extension on the auger. To do this, remove the barrel of the auger from the auger handle, add the extension to the handle, and reattach the barrel. When disassembling the barrel from the handle, you will likely need one person holding the handle and another person with a wrench to loosen the barrel. This is necessary because during coring, the barrel self-tightens. After removing soil between 42 inches and 66-inch depths, the 6-foot soil sample is collected via 2 6-inch corings. Don't forget to decontaminate equipment just prior to getting the actual sample. Store the sample in Ziploc bags and place in the cooler with ice. The two tables are now to be moved from proximity to the first hole and relocated 25 to 40 feet away from the first boring. The second replicate soil core is now taken, repeating the procedures used for the first core. Make sure all equipment has been decontaminated prior to starting the second core. After successfully obtaining the second set of soil samples, the procedures are again repeated to get a third soil core. There should now be 9 soil samples, 3 replicate cores with 3 soil samples per core for this plot. Field blank and equipment blank also need to be collected at each plot. Utilizing fresh gloves, these blanks should be collected at a point just before or after the second coring. For the field blank, open the field blank bottle with the deionized PFAS-free water that was previously filled in the laboratory. Pour this water into a second empty field blank receptacle bottle, cap the second receptacle bottle, and place it in the cooler. The equipment blank is obtained after decontaminating a piece of equipment. Collect an equipment blank as follows. Open an equipment blank receptacle bottle with DI PFAS-free water, pour the water over the decontaminated equipment, and collect the rinsate in a stainless steel bowl. Pour this rinsate into the equipment blank receptacle bottle and cap the bottle. This is best done with 2 people, one to hold the equipment blank receptacle bottle and cap, and one to do the rinsing. Both people should have clean hands and a clean pair of nitrile gloves. The travel blank should remain unopened and taken back to the lab. All blanks should be placed in double Ziploc bags and put in the cooler. Soil samples and blanks in their Ziploc bags should be placed in a cooler containing sufficient ice to keep samples cool during transit time. Do not use chemical freezer ice packs, as those can be a source of PFAS contamination. Samples are then immediately transported back to the lab and stored at 4 degrees C until shipping. We will also be asking you to get water samples used for irrigation, and these will be collected in an 8-ounce HDPE labeled container, either during an irrigation event or directly from a well. Any equipment used should be decontaminated, and fresh gloves should be worn during sampling. We will also ask you to get a sample of biosolids, cake biosolids preferably, from a wastewater treatment plant. And to do this, we will have someone with a fresh pair of gloves collect a 20% solids biosolid sample, filling an 8-ounce labeled HDPE container. Routine information on the biosolids should be recorded and sent electronically to the University of Arizona. Record required information on the chain of custody form, including sampling date and time, sample ID and location, and sampler name. Record the same required information on the sample bottle labels and any other information requested on labels. The information on the sample container labels and chain of custody must match. Be sure to retain a copy of the chain of custody to keep for your records, in addition to the one that will accompany the samples to the University of Arizona. If no other means of retaining a copy is available, take a digital photo of the chain of custody or request that the lab send you a copy. So there you are. You now have all the information you need to carefully sample soils for PFAS analysis without contamination. Keep in mind that this is fieldwork and it can be difficult. Selection of the site is critical. If the soil is too sandy, it will fall out of the auger. If it's too fine textured and wet, it will be very difficult to remove from the auger. Also, there may be issues with getting the 3-foot and the 6-foot sample due to rocks, caliche, or other impediments. The 1-foot soil sample is the most critical since this will have the highest PFAS soil concentration. The paired data set of, in particular, the 1-foot sample and any groundwater samples are of particular interest to the project. You will probably be able to get the 1-foot and 3-foot samples, but may have difficulties with the 6-foot. Do the best that you can, and I'd like to thank each of you for being part of the project and viewing this video. You can rest assured that your efforts are critical to evaluating the safety and sustainability of land application of biosolids across the nation.